This guy looks way more fun than the last guy. So first, let's do our first derivative test. We have f prime of x equals, we have 1x to the second power minus x minus 2. Very nice and pretty. I set this equal to 0 to find my critical points. This is a quadratic, so I must factor. I get x minus 2 times x plus 1. That equals 0. And I get two critical points here. I get positive 2 and negative 1. So I'm going to draw my sine line graph. This is an x-axis. I have negative 1 and 2. Got my three intervals. Let's see. Before negative 1, I suppose I'll pick negative 2. So I plug negative 2 into my first derivative. See what I get. I get negative 2 raised to the second power minus negative 2, and then minus 2. Let's see what we get here. Actually, I'm just going to write it underneath. We have 4 plus 2 minus 2, so this equals 4. We really just care that it's positive, though, because that 4 is a slope. Alright, let's pick another one. I'm going to pick 0 because it's in between there. If ever I can pick 0, I will pick 0. It's the simplest one to choose. So we have subtract 0, this is 0, this equals negative 2. So we have a negative. So we're increasing then decreasing. And now let's see the last one. The last interval right here. I'm going to pick a 3. So f prime of 3. This is going to equal 3 squared minus 3 minus 2. That's going to be 9 minus 3 minus 2. So that's 5. 9 minus 5 is going to be 4. We have a positive again. And so in this case, we got something really clean going on here. We don't have like a double signage right here. We have increasing, then decreasing, and then back to increasing. Now, whenever the sign changes like that, at a critical point, we know that we have a max or min. Now, if the line is increasing, then decreasing, clearly we would have a max. If the line is decreasing, then increasing, we would have a min. Okay. Alright, so let's do our second derivative test, and then we can see if we can graph this bad boy. Alright, f double prime. Let's see, I do another derivative of that guy. Let's see, we would have 2x minus 1. Set it equal to 0, and we would get 2x equals 1, x equals 1/2. And so at 1/2, we have a possible inflection point. We must check. So before the 1/2, we can pick a 0. So in f double prime, we're going to plug in 0 to see what I get. I get 2 times 0 minus 1. And it looks like we're going to get a negative number. So I'm going to put negative right there. So that means we're concave down before 1/2. And then I'm going to pick another number after 1/2. Let's pick 1. So I have 2 times 1 minus 1. And that is going to equal positive 1. So we're positive. So how does this look all on one sine line graph? Let's see. I'm going to draw my x-axis right here, and let's put the 0 right there. And then we need a negative 1. Let's put a negative 1 right there. And then this would be 1, and this would be 2. Cool, that works. We would put our y-axis right at the 0. And let's draw our critical points and inflection point. So we got our critical ones are at negative 1 and 2. And then we have an inflection point at 1/2. Now this is nice because it's very easily spaced, so it should be easy for you guys all to see. Now we should have a double sign between each of these dotted lines. Before the negative 1, we have an increasing line, and this is all the numbers before 1/2, so that includes negative 1. So I have a plus and then a minus. So I have plus and then a minus. Actually, let's use black. Plus minus. And then between that guy and that guy, because I'm crossing over orange, I know that our sign's going to change. Well, I check my sine line graph to see if it's going to change, and it does. So I have minus. And then because we don't cross over the purple line, I know that we're still on the left side of 1/2, so it's going to be minus. It's a minus-minus curve. All right? Let's see here. Between that guy and that guy, let's see. First, we got to do the orange sign, which we're still between -1 and 2. We don't cross over an orange line here, so that means we're still going to be negative. And then our next sign, because we cross over the purple, that means the purple sign most likely is going to change. So now we have positive. Now we're crossing over an orange line, so I'm pretty confident this is going to change, and I double check my sign line graph to see if that does change, and it does. So my first line is positive, and then we're positive again because we don't cross over a purple line. All right, so we have actually this is kind of neat, it's probably why it's an example, we have all different possibilities of a curve. We have all 4 types. We have, well, I'll just do it. But before I do it, I want to get a Y-intercept on this thing so I can get an idea of where my curve is at. If I plug 0 into all these, I'll get 3. So let's see. Let's count by ones on this one. Call that a 3. Cool. So I need to make sure I just go through that point. All right. Actually, I think I want to draw what's happening between these 2 dotted lines first, too. It looks like we're decreasing and we're concaving down. So I'm going to decrease and concave down right here. And because this is a critical point, we're going increasing and decreasing on this line. I know that this is supposed to be a max right here. So we should be increasing and concaving down up to that. And then between these 2 lines, it looks like we're decreasing and then concave up. So we're still decreasing, we just start concaving up. So we're just going to start going this way. And then we're at a minimum, which makes sense because at 2, we are decreasing, then increasing. Right after this, we're increasing and we're still concaving up. Boom. Okay. There you have it. I know it's not exact. It's not exact by any means. I know that I might not even need to pass the x-axis right here, but this is just a rough sketch. We get an idea of what our function looks like, and that's all you're expected to do with the first derivative and second derivative tests. Now, if this is a super easy problem and it's easy to find the x-intercepts, then go for it. But this is really all you need to do. You need to know how to use the first derivative and the second derivative tests in order to sketch a curve.